Power over Ethernet PoE. Injectors switch PoE standards. Imagine power over Ethernet, or PoE, as the ultimate two-for-one deal in the world of networking. Traditionally, every electronic device on your network required two separate connections: a copper Ethernet cable for data and a bulky power cord plugged into a wall outlet for electricity. PoE changes this fundamental rule by allowing a single standard Ethernet cable to carry both high-speed data and the electrical power needed to run the device simultaneously. For a professional IT technician, PoE is not just a convenience, it is a critical architectural tool. It allows you to install devices like wireless access points, security cameras, and VoIP phones in high ceilings, on outdoor poles, or in deep warehouse aisles where running a traditional electrical outlet would be impossibly expensive or physically dangerous. To truly master this technology, we must explore the hardware that provides the power, the handshake that keeps devices safe, and the evolving standards that allow us to power everything from a tiny sensor to a high-end laptop. The source of power, PoE switches versus injectors. In a PoE ecosystem, we categorize hardware based on whether it gives the power or takes the power. The device providing the electricity is called the power sourcing equipment, or PSE. The device receiving that electricity, such as your security camera, is called the powered device, or PD. The most common way to provide power in an office environment is through a PoE switch. This is a managed or unmanaged switch that has the power circuitry built directly into its ports. When you plug a compatible camera into the switch automatically detects that the device needs electricity and begins sending it down the wire. This is the cleanest and most organized way to build a network, as it eliminates the need for power bricks and wall warts cluttering up your server rack. However, you will often encounter situations where you have a perfectly good network switch that does not support PoE, but you need to add just one or two PoE devices to the network. Instead of buying a whole new expensive switch, you use a PoE injector, also known as a midspan. A PoE injector is a small, standalone power supply with two Ethernet ports. You plug the non-powered data cable from your switch into the data-in port, plug the injector into a standard wall outlet, and then run a cable from the data-in power-out port to your camera. The injector effectively injects the electricity into the line, allowing you to bridge the gap between legacy hardware and modern powered devices. The safety handshake, detection and classification. A common fear among new technicians is, what happens if I plug a regular laptop or an old non-PoE printer into a PoE port? Will it blow up the motherboard? The answer is a definitive no. This is because of the PoE handshake. When a PoE switch detects a new device is plugged in, it does not immediately blast it with 48 volts of electricity. Instead, it sends a very tiny, harmless detection signal. The switch is looking for a specific electrical signature, a 25,000 ohm resistor, inside the device. If it doesn't see that signature, it realizes the device is not PoE compatible and treats the port as a standard, data-only connection. This makes PoE safe to plug. If the signature is found, the switch moves to the classification phase. It asks the device, how much power do you actually need? The device responds with a class number, usually from 0 to 4, telling the switch its maximum power requirement. Only after this conversation is complete does the switch turn on the tap and deliver the requested electricity. The evolution of standards, from 802, 3AF to 802, 3BT. As our devices have become more powerful, the IEEE has had to update the PoE rules to keep up. You must know these three primary standards to ensure you aren't trying to run a high-power device on a low-power switch. The original standard is 802.3F, simply known as PoE, finalized in 2003. It was designed to provide about 15 watts of power at the switch port, after accounting for some line loss, which is the electricity that turns into heat as it travels down the long copper wire. It delivers about 12.9 watts to the device. This is perfectly sufficient for basic VoIP phones, simple door sensors, and older wireless access points. As wireless technology moved into the high-speed 802.11n and a C eras, 15 watts wasn't enough to run the faster processors and multiple antennas. This led to 802.3AT, commonly called PoE+. This standard doubled the power, providing up to 30 watts at the switch and delivering about 25 watts to the device. This is the current workhorse of the industry, used for high-end security cameras with motors that tilt and zoom, as well as modern Wi-Fi 6 access points. The newest and most powerful frontier is 802.3BT. Known as PoE++ or high-power PoE, this standard is a massive leap forward, utilizing all 8 wires in the Ethernet cable to carry electricity instead of just 4. It is divided into 2 types. Type 3 provides 60 watts, and Type 4 provides a staggering 100 watts of power. This is a game changer for the modern office. With 100 watts, we are no longer just powering phones and cameras. We can now power entire desktop computers, large flat-screen displays, intelligent LED lighting systems, and even high-speed heating elements for outdoor security cameras in freezing climates. The physics of the connection, the heat and distance problem. To master PoE, you must understand the physical limitations of sending electricity over thin copper wires. The first limitation is distance. Like all Ethernet connections, PoE is strictly limited to 100 meters, or about 328 feet. As the cable gets longer, the electrical resistance increases, causing the voltage to drop. If your cable is too long, the device might have enough power to wake up, but it will crash or reboot the moment it tries to perform a high-power task like turning on its infrared night vision lights. The second limitation is heat. When you run 60 or 100 watts of power through a bundle of Ethernet cables, they get warm. If you have 50 PoE cables tightly packed together in a plastic conduit, the heat can build up until it begins to degrade the data signal or even melt the plastic insulation. As a professional, you solve this by using higher quality cables. Category 6 and Category 6A cables have thicker copper wires than the older Category 5E. Thicker wire means less resistance, which means less heat. In high-power PoE++ installations, using the correct category of cable is a requirement for both performance and fire safety. Managing the power budget. From an administrative perspective, one of the most important tasks is managing the power budget of your switch. A PoE switch might have 24 ports, but it does not have enough internal electricity to provide full power to all 24 ports simultaneously. For example, a switch might have a total power budget of 370 watts. If you plug in 10 high-power cameras that each require 30 watts, you have used 300 watts. You only have 70 watts left. If you try to plug in 3 more cameras, the switch will reach its limit, depending on how you have configured it. The switch will either refuse to power the new cameras, or it will load shed, meaning it will turn off the power to the least important device to make room for the new one. To manage this, a technician uses the Managed Switch interface to set priorities. You can tell the switch that your VoIP phones are critical, while the wireless access point in the break room is low priority. This ensures that if the power budget gets tight, your most important business communications stay online. Security and troubleshooting. From a cybersecurity perspective, PoE adds a layer of physical security. Because the switch controls the power, you can use a script to automatically turn off the power to the wireless access points after business hours. This effectively shuts the door on hackers who might try to sit in the parking lot at night and attack your Wi-Fi. When troubleshooting a PoE failure, your first tool is the link light on the switch. If the light is green, the handshake was successful, and the device is powered. If the light is amber, it often indicates a power mismatch. Perhaps the device needs PoE+, but the switch only provides standard PoE if there is no light. The handshake has failed. This usually means either the cable is broken, the device is not PoE compatible, or you have exceeded the switch's power budget. By mastering the safe-to-plug, handshake, the different tiers of the 802.3 standards, and the careful management of the total power budget, you will be prepared to build and maintain the high-tech, single-cable infrastructure that powers the modern enterprise.